Okay. We've done a lot of, guys, we've done a lot of finding the, having the equation and then making the table and finding the graph. And this time we're going to go backwards. We're going to have the graph, we're going to make a table, and then we're going to find the equation. What I want to do is find the y-intercept right here, and I'm going to put a coordinate point there, like a dot. And then I'm going to find another nice dot. All you need is 2 really to be able to do these problems. Okay, now when you write your table, you should go from left to right. So I'm going to start with this dot. This dot is at -110. And this dot is at 0, 5. Okay, so what is the multiplier? Yes. And you could put 0.5 or you could put 1/2. I don't care either way. Okay, so y equals, the start is 5. So remember, A is whatever is next to the 0, and B is the multiplier to the x. Okay, number 10. Okay, I'm gonna mark this one and this one. Okay, what's the multiplier? Yep. And what is the start? 4. Y equals 4 times 2 to the x. That's it. I don't think we have anything in the packet otherwise. But we do have stuff in the notebook, so okay, so all week we've been working on inequalities. We're working on inequalities again, but these ones have 2 variables. And we're gonna do problems 40 to 43. 40 is gonna take us a while. 41 and 42 are notes, and 43 is like a practice one. Homework is 45 to 51, and it says, in math, I use this thing called the guess and hope method. Instead of the guess and check method, it's the guess and hope method. Oh, Mrs. Talbot, you're hilarious. Okay. All right. So for number 40, okay, guys, start with this at the top. So you're gonna need like a full side of paper almost for number 40. You're gonna write this stuff, and then you're gonna make me a giant graph that goes out 10, -10, up 10, down 10. Does that make sense? 10, 10, 10, 10. I'm gonna bring your groups a slip of coordinates. Don't lose it. I'm gonna help you guys get going, don't worry. You might want a ruler. Pull it over this way. Yeah. Okay, so here's what my graph part looks like. It's 10, 10, negative 10, negative 10. Okay, so you guys are gonna need the points that I gave you, so grab those, or just put them in the middle. The first thing we're gonna do, number one, is we're gonna graph this line. So do you guys remember Monday, Tuesday? I told you whenever you have an inequality, the first thing you do is just go into denial and pretend it's equals. Okay, so what we're doing here is we're taking this inequality symbol and we're going into denial and pretending it's equals. Okay, so I'm going to graph this line. I'm going to start with the y-intercept of 3. I'm going to go up 3 for my y-intercept. And then the slope is negative 2, which means I go down 2 over 1. So I'm up 3 and then go down 2 over 1 and continue this pattern. So backtrack it and forward track it. Is my line hilarious? Super funny. Yeah, so I went up 3 for the y-intercept, and then I went down 2 over 1. And then I backtracked back 1 up 2 a bunch of times. So I now have this line. Okay. Now you have a lot of space on your paper. And you guys have some coordinates that I gave you. I think there's 6 on each table. Guys, shh. And what I need you to do is bring me the true ones. Okay, but let me show you what I mean first, because we had a debacle yesterday. Okay, Rowan, can you read me one of your coordinates from your sheet there? Any one of them. 1, 6. Okay, can you guys all okay, first of all, can you chill, please? Okay, so this table, don't write this, don't write this, don't write this. This table has on their list of coordinates 1, 6. Okay, so this isn't, you guys are just watching, I'm just demoing. So this is an X and this is a Y, correct? So I'm gonna go 6 is greater than or equal to negative 2 times 1 plus 3. And I'm going to decide if this is true or false. So I have 6 is greater than or equal to 1. Negative 2 times 1 is negative 2 plus 3 is 1. Does that make sense? Anyone here? 6 is greater than or equal to what? You sure you got it? Okay, okay, is this true or false? Happy crocodile? Happy crocodile means true. Okay, so that means that Rowan or whoever's in charge in that group is going to tear off the coordinate 1, 6 and bring it over to me. You guys are only going to bring me the true ones. You're going to throw away, get rid of the false ones. Does that make sense? Yeah. Okay, so work on, in your groups, work on your coordinates you have. Plug them in just like I did here. Bring me the true ones. You guys only have 5. Ah, nice. I've already received my first one. Feel free to just write a T and F or an F on the paper and then rip them apart. Yes, honey. Yeah, rip them apart and then just bring me the true ones. It doesn't have to be perfect. They're going straight the trash can after this period. It's fine. Thank you. Okay. Perfect. Yes. 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 Yes.
Wait, how many are you read?
No idea. It's different in every line. Yep. Perfect. Nope. Every row is different. They're kind of random. So don't feel weird if you didn't get very many. I don't know. Perfect. That's correct. Every single one that I've gotten so far has been correct. Yes. Thank you. Thank you so much. I don't think so. Wait, I'm not looking at it. -3, 4. Nope. No, hold on. -3 is greater than or equal to -8 plus 3. I did this wrong. 4 is greater than or equal to 6 plus 3, so 4 is greater than or equal to 9. False. -2 times, wait, it'd be +6. Because -2 times -3. Okay, so this is 4. And then it's -2x. So -2 times -3 is +6. Plus 3 is 9.
Oh, okay.
Yeah. Take that one, take that one. Leader. Any more truths? Feel free to recycle your falses. Okay, that's it? You sure? Oh, okay. Okay, so what I need you guys to do next is to follow along with me and graph all of the truths. So 2, -1, already graphed. Great. 1, 4. 2, 7. I feel like I'm playing bingo. 4, -4. 3, -3, already graphed. Excellent. 1, 1, already graphed. 5, 6. 4, 3. 5, 4. -1, 5, already graphed. 0, 5. 0, 3, already graphed. 4, -5, already graphed. Well, getting lazy now. 1, 6. 2, 4. Are you guys able to tell which side is true and which side is false? -1, 6. 2, 2. I like to think of it as above the line because the symbol is greater than. But we have to be really careful when we talk that way. But yes. Okay. So I'm going to use the fancy vocab from yesterday. How do we represent the solution set of an inequality on a number line? I'm saying fancy vocab. How do we represent the solution set on a number line in an inequality? What does the answer look like in an inequality on the number line? I'm looking for the word arrow. Oh, I'm looking for, okay, if you don't know, every inequality is different, but they involve arrows. Even the Baymax situation is technically 2 overlapping arrows going in opposite directions, which I don't want to confuse you with, but when you're representing a solution set on a number line, it's with an arrow. And when I mean solution set, I mean all of the numbers that work in that inequality. So all of the places where it would be true. Okay, so the question is, how do we represent a solution set? Can we graph all the dots that work? Is that possible for us to do? Graph all the dots forever that work in this equation? Okay, so I'm going to show you guys Desmos. I'm going to show you what we do for 2 variable inequalities. This is what it should look like in your final answer. So do we all agree that this is the true section? Okay, so what you do is I like to get a colored pencil because I'm nerdy, and I will shade the side of the line that is true. I want you to think of this shading like the arrow on the number line, but this is 2D instead of 1D. You You guys know what I mean by 2D instead of 1D? Okay, so everything we've learned so far has a boundary point, which would be open or closed, and you'd have an arrow. And with these, they're two-dimensional. So you have a boundary line and your shading area on either side, depending on what side is true and what side is false. But we have a lot of evidence in this problem to show us which side was true and which side was false. A lot of points. You guys really only need to do one. And most of the time, I'm going to choose 0, 0 because it's the easiest one to plug in. Okay, once you guys get your shading done, then we're moving on to number 41. This, by the way, is a strict inequality because it has the or equal to on it. I need more crocodile posters, ones that have the or equal to, but I don't really know what it would look like on the crocodiles. But like, what would the little line underneath it be? Like the ground? Yeah. Or water. Ooh, I like water. Okay, you guys, here are the next. This is 141 and then 142. Okay, guys, so let's go. Example 1. Number 1 is just like number 1 for every inequality we do. Pretend you have equals. Y equals negative 2x plus 3. Okay, now with these questions, with inequalities, you still have to decide something about open or closed. So this would be closed and this would be open. Does that make sense? Closed, open. Okay, so when we're doing lines, you can't really do an open circle for a line or a closed circle for a line. What you do is solid or dashed. This one ends up being solid because it's got the or equal to on it, and then this one will end up being a dashed line. Okay, so pretend you have equals, so go up 3 for your y-intercept. And then slope is -2, so down 2/1. This is the same line we just did. And then make it solid. I'm going to warn you that I somehow frequently forget to dash the lines. And sometimes I'll have to go through with whiteout and make little strips of whiteout along the line. And it's really unattractive. But it was like my thing in high school. I'd always forget about the dashing. I don't know. Anyway, okay. So step 1, pretend you have equals, graph the line, and decide if it's solid or dashed. Step 2 is test a point. You guys tested a lot of points and told me which ones were true and false, right? So I am going to test 0, 0 almost every time. Does anybody know a time when I could not test 0, 0? Yes. Yeah, okay. So if my line happens to go through the origin, if it goes through 0, 0, I can't use it because I won't know if I should shade on either side of it. So I can test 0, 0 right now because it's not a solution. It's not on the line. Okay, so I'm going to put 0 is greater than or equal to -2 times 0 plus 3. This is exactly what you guys did a minute ago. Do you have to do 0, 0? No, you can do any point you want. Okay, 0 is greater than or equal to 3. False. Unhappy crocodile. He gets 0 and there's 3 available. Okay, what that means is this side where we plugged in 0, 0 is false. So the other side has to be true. You got to think of it like the arrow on the number line, but it's 2D. And then step 3 is to shade the true side, just like you drew the arrow to the true side, shade the true side. Great time to break out the old colored pencils. Okay. Example 2. Number 1. Pretend you have equals. Y equals -2x plus 3. We're going to be really tired of graphing this line in about 2 seconds. This time, however, it's dashed. Can you guys tell the difference between solid and dashed? Okay. And then you have to like make yourself remember to dash. That's the hard part for me. So up 3, down 1/2. I don't think the testing is going to change. I'm still going to test 0, 0, which I'm going to note right here. I think we're still gonna get the same result. So, oh no, we're not. 0 is less than -2 times 0 plus 3. 0 is less than 3. True. 0 is indeed less than 3. Okay, so that means at 0, 0, y plugged in is a true dot, and the other side of the line is false. And we want to shade the true side. You might be thinking to yourself, Mrs. Talbot, is there a final answer for these? The answer is the graph, because there's infinite coordinates here. We can't write them all out. So the graph is the answer. Okay, almost done. This is the end right here. Okay. All right, so here we go. Let's practice. Step 1. Pretend you have y equals -1/3 x minus 1. Is it going to be solid or dashed? Dashed. Okay, so let's remind ourselves how we graph this. So go down 1 for the y-intercept. And then the slope is -1/3, so you go down 1 over 3. And I like to go up 1, back 3. Just to, can you stop? Look, I remembered to dash. I'm so proud of myself. What? You're laughing at my inability to remember to dash? Yes, yes, yes. Okay. What coordinate do you guys want to test? Yeah, I want to test 0, 0 because I'm lazy. Can I test 0, 0? Yes, because my line does not go through it. Okay, so back up to the original. 0 is greater than negative 1/3 times 0 minus 1. 0 is greater than negative 1. True. Okay, so what does that mean? That means at 0, 0, I'm going to put a true, like right next to it. And on the other side of the line, I'm going to put a false. And then I shade to the true. I'm hoping that you guys see this is very much like one variable inequalities. It's just that it's 2D. And the nice part is there's no final answer, so you don't have to remember that part. I feel like there's a bigger probability of remembering an open circle than there is to dash a line, though, and I'm not sure why that is. I think it's because we're just so ingrained to draw the line. But all right, last problem of the day. Then a few of you said you needed me to get you unstuck from your escape room, which I will do in a moment. Okay, last one. Step 1, pretend you have equals y equals 4x plus 2. And this one is going to be solid. Thank goodness. I made it. I'm in the clear. Okay, so when I go up 2, I'm going to go up 4 over 1. I'm out of the, it's okay. Then I'm going to go down 4, back 1. John, did you do them without me? Are they that easy? Is it too easy? Okay, can we test 0, 0? Yes. Okay, 0 is less than or equal to 4 times 0 plus 2. 0 is less than or equal to 2. It's true again. Well, that's good, I guess. Okay, so true. So I'm going to put a little dot at the origin and put true next to the origin. Put false on the other side of the line. You guys know why I put the true at the origin? Because I plugged in the origin. Okay, and then last shading. Did half of the class do this without me? You didn't need me, is what you're saying? Oh, that's good. Did anyone notice my Squishmallow t-shirt? That was Squishmallow mixed with the Friends show. My